So guys, I am upgrading my boost converter this time around, and you can see let me show you my solar panel voltage that I am having. The panel usually give me 6 amps, and when there is full sun I should have 39 volts. Now this boost converter is programmed to give me constant output of 15 volts. So let's test it and see it function. Now I disconnect the fan, so I will connect it to the output of the boost converter, which is this one. I'm planning on using this boost converter to power the inverter that will power my house, and that will give me up to 200 watts of load. Now this is my constant output, 15.2 volts. Now we'll take it down to 20 volts so you can see it. 15.2, 15.3 volts. Now let me connect the fan to it so you see if the fan start up what we will be having. Here's the fan. I use this amount of capacitor because they are rated low. I'm trying to get the ESR down, that's why I use capacitors like this. And you can see the fan output. You can see I still have my 15.2, 15.6. With or without the fan, the voltage stays stable at 15. Now I will connect this inverter. Then I will first of all use this 10 watts bulb. This 10 watt bulb. Is it 10? Yes, it's 10 watts bulb. Then I will go ahead to use the 100 watts bulb to see if it can carry this 100 watts bulb. And if it can carry this 100 watts bulb, that means it can carry 20 pieces of this bulb. Now I have connected the inverter to it. Look at my inverter. This inverter can give me 400 watts output. Now you see the voltage rises up slowly. That's how it is. That's how I set it to be 200 volts, 210 volts. Now I'll use this 10 watts bulb without any battery. You can see there is no battery here. It's just my inverter, my solar panel. Now there is no battery here. You see how it is, and look at the voltage. You see the 15.2 is not even dropping. To show you how strong the boost converter is, it's still giving me 15.3 volts, 15.2 volts. You can see the boost converter working very well. The fan is not even blowing the boost converter yet. Now let's try the 100 watts bulb to see if it will power the 100 watts. Guys, this is an experiment at its raw, what is it called? This experiment has now, that is bad because it draws down the current and the voltage drops, so which means the solar panel doesn't have enough strength to sustain the whole power output. Look at it. It drops the voltage. But let me see my solar iron, which is 60 watts, which is this. You can see 60 watts solar iron work perfectly. Look at it. Let me off the light so you can see it properly. Okay. Now 60 watts coming in. You can hear the difference from the sound, but the voltage is not even changing. You can hear the difference from the sound of the fan, but the voltage remains stable. And look at it here. You can see the voltage drop, which means the solar panel is not strong enough to sustain 100 watts. In that case, I will have to have 100. The solar panel is actually rated 200 watts. You can see my solar iron. This voltage is dropping, which is the voltage from the boost converter on a 60 watt solar iron. But this voltage is not dropping. It's still around 210 to 20 volts. You can see it. It's not even dropping. It just shakes a little to So it's just the fan that makes that noise. So in conclusion, I can power my 60 watts soda iron. Let me put it so you see. I want the soda iron to stay. Now the soda iron is connected, and let me also put my 100 watts bulb, my 10 watts bulb together. You can see. Now this one is actually drawing it down, which means the maximum it can take is 60 watts. It cannot really take more than 60 watts. You can see how bright the bulb is. No battery here, no nothing. No battery, just the system with the solar panel.